This is Gavin and Jeffrey's model of the interior of the Earth. The inner core is solid. It's 750 miles, mostly iron, little traces of nickel. The outer core is liquid. It is made of iron and nickel. It's 1,400 miles thick. The semi-solid mantle is 1,800 miles. It has magnesium, iron, silicon, and aluminium, and the crust is 25 miles. It's a solid. It has oxygen, silicon, calcium, aluminium, and iron.
So, how do we know that the Earth's outer core is liquid? Well, how we know is due to earthquakes and seismic activity. Now it's all dependent on waves. So we have the primary wave, which is very fast, and it can pass through anything, pass through all the layers of the Earth. So right here we have a gray P wave that goes throughout the entire Earth structure. Now here we have the S wave. The S wave is slow, and it can't go through liquid because it's not fast enough. So that's why it kind of just bounces off, called refraction. So this is why some places feel P and S waves, and then this is and this is why some places only feel P waves. So now you may say, how do we know this? Well, scientists use a thing called a seismogram that kind of types out the seismic activity and what kind of waves come. And they've discovered that there are two waves, P waves, S waves, and that the S wave can't just go through liquid. It's impossible.
Mm-hmm.
So the dynamo theory. Well, to dynamo theory now. The dynamo theory is a large dynamo, or is a theory that we have a large dynamo or magnetic field generator in the outer core of the Earth. The outer core is liquid, so it would move. So when the Earth spins, so does the liquid. And as it spins, the molecules inside get really excited, and they create an energetic electric current due to the conductive metal of iron. So how do we know that the outer core is iron and the Earth has a magnetic field? Well, it's of course because once it's due to the seismic waves, and S waves cannot puncture dense metals, and we have the northern lights, aurora borealis, that happens when one side of the Earth kind of gets a little bit too magnetized, which would be this Earth, this side, so it has to release that energy somehow through the northern lights. So we have convection currents. Now, convection currents are caused by heat transfers by motion and movement of matter in a gas state or liquid state. So, as you see here, the less dense metals kind of heat up and rise. Then they cool once it gets to the outer, close to the crust. And then it sinks back down, and that's how it keeps on going. It just moves up, moves over, sinks back down. Now, lava lamps are used to show the way the outer core looks in the Earth. Matter in a convection cell moves fast and rises because of the lower density, and it heats up. After it reaches the lower part of the crust, it cools and sinks down, creating a convection current.
When plates converge, they will cause a mountain to form. Plates move because of convection currents going through the Earth. Matter cycles at the boundaries by the diverging of the plates. Moving magma to the surface from the mantle.